Okay, so welcome to today's lesson where we'll just be revising, okay, the quiz one that your friends wrote, like the January intake, okay. So I don't know if it's going to be the same with this intake, okay, but in January they had 4 sets of quizzes, okay, based on the same concept. So group A, they wrote their quiz, group what, just like that, okay, but based on the same concept. And some of the questions were just the same. Yeah, so I'm sure they are also going to do that with you guys, okay? So on Drive, there are already 3 videos for these quiz revisions. So if you didn't watch them, I urge you to watch them before you go write your quiz tomorrow, okay? So there are 3 videos already. With this one, there are going to be 4 on the quiz 1 revisions, okay? So make sure you watch all those videos. Okay, so let's go straight into answering the questions. So the paper that I'm using as answers. So I'll be explaining how we got those answers. Okay, so if you have any questions, you're free to ask. Okay, so the first question here, they're saying, we have a table here, and then they're saying, answer question 1, 2, 3, based on the table below. Okay, so the first column there, we can see the number of protons, the number of neutrons here, the number of electrons they are there, the mass number, and then the atomic number, and then at the end there we have the net charge. Okay, so the first question there, they're saying indicate the atomic number. Okay, meaning we have to find this number here. And we said the atomic number is just the same as the number of protons. So the number that we are going to put here should be the same with the number that we're going to put here, okay? So let's fill in this table and then we can answer these questions. Okay, so where can we start? So we can look at the number of electrons and the charge that we have. So remember, in a neutral atom, we have equal number of what? Protons and the electrons. Okay, so meaning that atom there has a charge 0. But if you see a charge here, it means one of the 2 things happened. It's either the atom lost electrons or it gained. Okay, so if it gained electrons, it will have a negative charge. If it lost electrons, it will have a what? A positive charge. So here we can see that here we have 2 minus. So 2 minus there, it's a minus charge of 2. So meaning this atom gained extra 2 electrons, okay? So it has more of the negatives now. No wonder here there's 2. So if I have 54 electrons there, it means initially I had what? 52, and then I gained 2 to make 54, and the charge changed to 2 minus there. So we are going to say we had 52 initial electrons. It means that should equal what? The number of protons. So here we're going to put 52. Even here we're going to put 52. Okay, then let's fill in the mass number. So we know that the mass number is just the addition of the number of protons plus the number of what? Neutrons. So when we add this and this, we are getting 128. Okay, so you fill in this table and then you can answer this. So indicate the atomic number. We see that the atomic number is 52 there. So no wonder the answer here, we are saying what? It's C. And then here indicate the mass number. We see it's 128. Where is the 128? It's on option A. Okay, and then they're saying how many number of protons, okay? So the number of protons, same as the atomic number, always. So it's the 52, but now it's on option what? A. Okay, so this is a very short revision. And then number 4, okay, number 4 there, they're saying how many total atoms, okay, how many total atoms are in 3.10 multiplied by 10 to the power 11 molecules of this compound there. Okay, so how can we solve this? We have to establish what we call as a ratio, okay? So we have to establish the ratio of the number of molecules to the number of what? Atoms. Okay, so when we look at this molecule here, we can see that it has how many atoms? It has 1p and 3 of the L's, of the H's, I mean. So it means we have one molecule, okay, one molecule of this. So we can say one molecule of PH3. Okay, one molecule of PH3. Why is my pencil misbehaving? And this should give you how many atoms? 4 atoms. Okay, so this is the ratio of the atoms to the molecules. So if I have one molecule of this, it means I have what? 4 atoms. Now I have this number of molecules. How many atoms am I going to have? So you just do a cross multiplication. Yeah, so let's solve it on the board here. So we are saying one molecule of PH4, okay, contains 4 atoms. Okay, what about the number that we had there, which was 3.1 multiplied by 10 to the power, was it 11? Okay, so let me check. Yeah, so 3.1 times 10 to the power 11 molecules. So how many atoms is this going to give you? So you say X and then you cross multiply. Okay, so X multiplied by 1 will just be X is equals to, and then you multiply this number here multiplied by 4. Okay, so you can get your calculator and then you try to multiply that. Okay, so you can just multiply the part that does not have the 10 to the power something. So I'm going to multiply 4 multiplied by 3.1. Okay, so when I multiply that, I'm getting a 12.4 multiplied by what? 10 to the power 11. And these now will be what? Atoms. Okay, and then from here, what can we do? We can make this number here to be in scientific notation. Okay, so scientific notation, we make sure that this number here is greater than 1, but it is less than 10. So meaning we have to move this point here one step to the what? To the left like that. So it means we are going to have 1.24 multiplied by 10 to the power 11 what? Atoms. So this is the answer that we are going to get there. Okay, and then you go on your options, you check where you have here. Okay, so here I moved the decimal place. It means here I must add a 1 because I'm moving to the left. So there the power should be power 12. Okay. So because I'm moving this decimal place to the left, I add a 1 to this. So this would be power 12, not power 11. Okay, so this is the answer there. And then we check on our options if we have it. So we can see here, the first one there was our answer. That's how you get it. Okay. Okay, so if you have any questions, you're free to ask. Otherwise, we'll go to question 5. So question 5, they're saying the concentration of copper in a copper ore. Okay, so a copper ore is something that has copper and other minerals. Okay, it has not yet been purified to be only copper. So the concentration of copper in this copper ore was recorded as 0.71 grams. Okay, and then they're saying the true concentration according to the certificate was 0.88 grams. Okay, determine the absolute error in the measurement. Okay, so here you just have to know the formula for the absolute error. So absolute error is equals to the modulus, okay, of the true value minus the recorded value. Or you can say recorded value minus the true value. It doesn't matter, okay, because you have these modulus that will make whatever value that you get inside here, they will make it a positive. So let's subtract. So we have modulus of the true value, which is 0.88 minus 0.71, then modulus. Okay. So you punch that into your calculator. What are you going to get? So 0.88 minus 0.71, I'm getting is 0.17. So 0.17, and we know that these measurements were in grams, so this will be grams, like that. Okay, and we see that this is the same answer that we have on what? On A. So no wonder A there is the correct answer. Okay, let's go to question 6. Question 6, they're saying evaluate that given expression there. Okay, so evaluate this expression. So here, what they're testing you on is your understanding on how to add significant on how to add numbers that have different significant figures, or how to divide numbers that have different significant figures. Okay, so the rule is when you are adding, okay, when you're adding or when you're subtracting, okay, two numbers that have different number of significant figures, your final answer, okay, should have the same number of decimal places as the least number that has fewer decimal places. Okay, so if, for example, before I even solve this, if, for example, I have 2.1, and then I have another number, let me say 4.12. Okay, so when you add this, okay, when you add this, you're going to get 2.6. Okay, so this is the answer that you get when you add. Okay, but your final answer, you won't express it as 6.22. No, that would be wrong. Okay, so the correct way is to check which of these two numbers here have less number of decimal places. We see that this one here on top only has 1. So it means your answer should have the same number of decimal places as that number that has fewer decimal places. So this one here, the correct answer here will just be 6.2, because this one here has 1 decimal places. So it should match with one of the digits that you have. Okay, so now let's try to add this. So here, so minus and positive here, the addition and the subtraction, they go together. So the rules for the subtraction are the same as for the addition. And then for the multiplication and division, okay, if I have 2.1 being multiplied by 2, okay, if I multiply this multiplied by 2, I'm going to get 4.2. This is the number I'm going to get. How will be my final representation of the answer? So your final representation, when you are dividing or when you are multiplying, the final answer should have the same number of significant figures as the list of the two values here. So we see that this one here has 2 significant figures, the 1 and the 2. This one has 1. So it means your final answer should also have 1 significant figure. So here the final answer should be what? 4, just like that. Okay. So these are the rules that we are following here. So we'll start first by subtracting the expressions that we have on top there. Okay. So when we subtract there, we see that those guys have the same number of decimal places. Okay, so it means the answer will just be the same. So when you subtract 1.50 minus 1.00, you're going to get 0.50. So this is the answer, and then we're dividing this by this guy here. So this is meter 0.50. Okay. So on top, we have applied the rule for adding or subtracting. We see that this one at 2 decimal places, even this one at 2. So the answer should also have what? 2. And then when dividing now, we have to count the number of significant figures. So we see that in this number on top, okay, we have 2 significant figures. Even the number down there, we have 2 significant figures. So it means our answer should also have what? 2 significant figures. So when we divide this, most of you will say, if I divide this, my answer will just be 1. Okay, my answer will just be 1. But 1 there, if you represent 1 like that, it will mean that you only have what? 1 significant figure. But from the numbers that we had, our answer should have 2 significant figures. So how do you make 1 to have 2 significant figures? Just say 0.10. So this is still 1, but with 2 significant figures. Okay, remember the trading zeros, meaning the zeros after the non-zero digits, are always significant if there's a what? Decimal place there. So you just add the decimal place and another 0. You've made 2 significant figures. So you can see why this was our answer there, the C1. Okay, so if you have any questions, you're free to ask. Okay, otherwise, let's look at number 7. So number 7, they're saying the concentration of zinc in milk sample, okay, was recorded as 130 micrograms per gram of zinc. Okay, and then the question now comes, considering the uncertainty in measurements, which digit is uncertain in the given measurement? Okay, so we said the uncertain digit is the last significant figure in the given number. Okay, the uncertain digit is the last significant figure in the given number. So we see that here in this number 130, the way it is written there, the last significant figure here is 3, because this 0 here, there's no decimal place here. So the 0 there is not significant. So the last digit there to be significant is the 3. Okay, so 3 there becomes your uncertain digit. Okay, so this 3 here becomes your uncertain digit. Okay, so in case they ask you, the other question that they like is that what is the upper reading of this? What is the lower reading? And then what is the range? Okay, so once you identify your uncertain digit, okay, for you to find the upper reading or the lower reading, okay, you have to consider the position where this uncertain digit is. Okay, so if we remember the abacus, okay, we had ones there, tens, and then hundreds, just like that. So this 3 here is in the position of the what? The tens. So it means the uncertainty of this value will be 130 plus or minus what? 10. So meaning the lower reading there, or the upper reading will be 140. The lower reading will be what? 120. So 130 plus 10, you get this. 130 minus 10, you get this. So to find the range, you just subtract these two. So the range will be what? 20. So in case they ask you, that's how you do it. Okay, so you can see why they picked 3 there as the uncertain digit. Always remember, the last significant value is the one that is uncertain. If you only have one significant value in a number, okay, it means that in that number, there is no uncertain digit, okay? And the range of that number will just be 0. So for example, the one that was on your assignment, which was this 60 here, the way it's written, it only has one this as the significant figure. So it means in here, we don't have an uncertain digit. So meaning the range of uncertainty there will be 0, okay? Because we can't find the upper and the lower values. Okay, let's look at question number 8, okay? And this question number 8 here, okay? The understanding of this question 8 will help you answer question 1 of tutorial sheet 2 in your tutorial manual, okay? So here they're saying, in short here, we just have to know how to get the mole ratios, okay? So here they're saying the moles of hydrated iron sulfate, and then they have given us this formula here to show us the elements that are there, okay? The moles of this guy here were determined to be 1.0 moles. And then they're saying determine the number of moles of hydrogen molecules present in the sample, okay? So I've noticed that students usually get confused by the term molecules and atoms, okay? So if they say molecules, they mean in groups of 2, okay? So if I have 2 of a certain element, I'll count that as 1 molecule, okay? But then if they say atoms, it means I'm counting one by one, those atoms, okay? So here they're saying determine the number of moles of hydrogen present in this sample. So we are just getting a mole ratio, okay, of the whole thing here, which is the hydrated iron sulfate, to the moles of what? The hydrogen molecules. Okay, so I think let me explain it here. So we have this guy here. I've forgotten how it is. Okay, S4 and then 7. Okay, so we have this guy here, and then we have S4 and then point. Okay, we will put the water of hydration here like that. Okay, so in that question they said we have one more of this whole thing here. Okay, how many moles of hydrogen molecules are we going to have? So we see that moles of hydrogen are molecules. Okay, so this here, the one I've represented in yellow, is one mole of what? Hydrogen molecule. Okay, so the mole ratio here, you just get the front number here. Okay, so in this formula here, we have 7 molecules of what? Hydrogen. Okay, we have 7 molecules of hydrogen. So it means if I add one of this whole thing here, it means I have 7 what? Moles of hydrogen. So no wonder here the answer, where is it? Here, the answer you can see is what? 7. Okay, but sometimes they won't ask for the molecules of, they won't ask for the moles of the molecules. They will say, if I have one more of this hydrated iron sulfate, okay, what are the moles of hydrogen atoms? Okay, so now there, the question will change. So there will be considering the what? The atoms. So you'll get that in this one whole thing here, how many atoms of hydrogen are there? You see that we have 14, because we're going to say 7 multiplied by 2. I hope you're following, guys. Okay. And then another question can be, if I have one more of this, okay? If I have one more of this, how many atoms of oxygen do I have? Okay, so you're going to say one more of this whole thing here contains how many atoms? You can see here we have 4, and then there we have what? 1. So 4 plus this, you're going to say your mole ratio is 1 to 5. Okay, so one more of this is equivalent to 5 moles of atom of oxygen atoms, like that. Okay, so know how to get the mole ratio there. Okay, know how to get the mole ratio. They can even ask you for this same ion here. So one more of this contains what? 1 ion, because we can only see this one. One more of this contains 1 sulfur, because we can only see 1. Okay. Okay, I thought of mentioning that because they just switch the language there. Okay, let's look at number 9. Okay, so number 9 is on the accuracy and precision. So they are saying the measured values, okay, were recorded as 87.6 meters, 87.5 meters, and 28.5 meters, and 28.4 meters. Okay, and then the question comes now. So they're saying the true value was 47.5 meters. Okay, and then they're saying which of the following is the correct word statement. Okay, before we even go on the statement, let us discover on our own, okay, what we have in those measurements. So the true value is this, 47.5. And then on the recorded values, you can see I have these values here that are greater than 45. Okay, and then I have also these values here, the 28 point something, that are less than what? 45. So we can see there that these measurements here will be affected by random errors because the variation is in both directions. Okay, we have numbers that are greater than the true value, and then we also have numbers that are what? Less than the true value. So it means the deviations there are going in both directions. So meaning this measurement here, the error will be affected by what? Random error. Okay, and then let's comment on the accuracy and the precision. So we see that there is no precision here because the measured values, some of them are 80 something, and then others are 20 something. Okay, so there's no precision. The measured values are not close together. And then if we talk about the accuracy, we see also that they are not accurate. Okay, because if I add this, I add this, I add that, and I find the average, okay, the value that I'm going to find there will not be close to this guy here. Okay, so you can try that on your own. Just add this, and divide by 4. You see that the value that you are going to find won't be close to this guy here. So it means, okay, that these measurements are not accurate. Okay, so we have determined. So we have said they are not accurate. Okay, not accurate. They are not precise. And they are affected by what? By random errors. And then you can go on your options now and check which options will satisfy all the conditions that we've discovered there. So A, they're saying the measurements were precise. Okay, so just by this statement here, we see that A is wrong. The measurements were precise again on B, wrong. And then here they're saying the measurements were not precise. Okay, that's good. The measurements were not, were inaccurate. Okay, that's good. And the measurements were affected by systematic errors. Okay, so that's the wrong thing there. Okay, because we determined that these were affected by random errors. So we can see that both A, B, and C are not answers. So the answer there would just be what? None of the above. Because it's not given. Okay, so even the none of the above can be the answer, guys. Okay, so just analyze the questions that you have properly, okay? And then you will see that even the none of the above can be the answer there. Okay, let's look at number 10, which is the last one. So we're saying the concentration, okay, of iron in powdered milk sample was recorded as 800 micrograms of zinc. Which digit, okay, in the recorded measurement, which digit is certain? Which digit is certain in the recorded measurements there? Okay, so which digit is certain there? Hello? Hello, guys, are you there? What can you say? Which digit is certain?
Yes, sir.
Huh? Hello, I'm asking a question. Which digit is uncertain there? I mean certain. The question says certain here. Which digit is certain there?
I think it's 8.
It's 8, right?
Yes.
Okay, what do you think it's 8?
Because it has one significant figure. The zeros are not counted.
Yeah, okay. Okay, so someone says there are no uncertain digits, yes. Okay, but the certain digit there should be the 8. I don't know why they put none of the above there. I don't know why they put none of the above. Okay, so the certain digit, we know that 8 is certain there because there's no uncertainty in that value there. Okay, so pick 8 as a certain digit because it's the only significant figure that we have there. Okay, so that's that. Unless you guys have any questions, you can ask me. Okay, so if there are no questions, I'll end this class. But as I told you, please go through the other 3 quizzes there on the drive. And then I also have the written solutions for tutorial sheet 1 and 2. So make sure you go through that for your revisions, and all the best as you write your quiz tomorrow.
Thank you.